Alright, today we're going to take a look at subtraction and talk a little bit more about what that means as we're working with problems in third grade this year. So in the past, our students have come across subtraction problems that looked a lot like this. Seth baked 12 cookies. He ate 5 of the cookies. How many cookies are left? So in a situation like this, our students have seen where we are taking something away, and they're used to this idea of having a larger amount and then taking some away, losing some, spending some money, whatever it is that's making them take away from that initial amount. So in our problem where Seth baked his cookies and ate some of the cookies, our students would recognize that this is a subtraction problem, that we're starting out with the 12 cookies, taking away 5 of the cookies for the ones that he ate, and he's left with 7. Our students may have modeled with a picture or some other way to show that. So we can see what's left. Well, now as third graders, we are starting to see some slightly different situations with our story problems. So here is the next example. Seth has 12 cookies. Jen has 5 cookies. How many more cookies does Seth have than Jen? So this is a similar problem. We still have our cookies, and it can be a little confusing for our students because there's nothing in this problem to suggest that we are taking anything away, which is what they typically think of with subtraction. But we've got these new words here, how many more? And so we want our students to start to see when we have that question, how many more, we're actually comparing these two values. So subtraction is not just taking away, but it's the difference or the distance between two numbers. So in our situation here, we weren't taking away any cookies, but we are comparing the amount of cookies that Jen and Seth have. We know Seth has more. We want to find out how many more he has. So one of the things that we will think about is how are these the same and how are they different? How are Jen and Seth's cookies the same and how are they different? So I drew a model here to kind of help us see what's happening with their cookies. For Seth, I drew a bar model here to show that Seth has 12 cookies. And then Jen, she only has 5 cookies. So we can see that Seth has more. And if we cover up what's the same here, we can see that Seth has 1, 2, 3, 4, 5, 6, 7 more. So we can see how many more he has. So they have 5 that's the same. And then from that 5, we're counting on to see how many more that Seth had than Jen. So the 12 and the 5 both have 5. But then the 12 has even more. It has 7 more, which leads us straight into the number line. This is how our students have been attacking these subtraction problems to model what's happening here. So on our number line, we're going to start at what is the same with these two numbers. They both have 5 cookies, but then Seth has even more cookies. How many more does he have? Well, if we count all of the spaces in between here, I did a jump of 5 instead of counting by ones, and then another jump of 2. And the 5 and the 2 gives us 7. So we're starting at what's the same, and then we're seeing what's different, how many more it takes to get to that 12, that value of 12. So let's take a look at this in a third grade situation. All right, so now we're working with some 3-digit numbers, and I have a story problem here about Jeff and Ryan, and they both have some baseball cards. Jeff has 321 baseball cards, and Ryan has 147 baseball cards. Again, we see the question here, how many more? We know that Jeff has more, but we want to know how many more Jeff has than Ryan. So here's where we're going to use our number line to help us do that. This is a subtraction problem where we're finding the difference or the distance between these two numbers. We know they're different from each other. We want to see how many more this 321 is. So we're going to actually start at 147, and we talk with the students a lot about how our numbers on the left of our number line are smaller, and as we go across to the right, we increase. So that helps them to see where to put the numbers from their situation, their story here. So if I start at 147, remember that's what's the same. Ryan has 147. Jeff also has 147, but he has even more. And that's what we're trying to find out. So a lot of our students will start with making a friendly number. So using this 7 ones, thinking back to first grade, learning how to make 10. So 147 plus 3 more is going to put us at a friendly 10, 150. Okay, our students also should know their combinations of 100. So we're trying to get all the way to 321 here. So we can make a big jump of 50, and that'll put us closer at 200. I still have to get over here to 321, so I can make another big jump of 100. And then one more jump of 21. I want to stop here for just a second because there are many, many ways to think about how to get from the 147 to the 321. A lot of our students who are having trouble starting, we will encourage them to start by making a friendly 10, but some of our students think about these in different ways, and that's fine. Some of my kids like to add 10 first. Some of my kids actually like to use the 47 that's in the number 147 and go straight to the 200. So there are many ways that we can get from 147 to 321. You don't have to do it in these exact jumps or these exact steps. So in order to find out our answer, what the difference is, we've got to figure out this total distance. We have 3, 50, 100, and 21. So if we combine all of these spaces here in between that we jumped, we will get the difference. I am going to add my 2-digit numbers together first. 50 is a friendly number because it ends with a 0, and so it's going to be easier for me to add to that 21. So that puts me at 71, and then let's see, I think I'll add the 3 next. That's going to give me 74 so far, and then I still need to add the 100. So the total distance between these two numbers is 174. So Jeff has 174 more baseball cards than Ryan.